In this video, we'll review the vertex form for quadratics. The vertex form for a quadratic is y equals a quantity x minus h squared plus k. To understand how to use it, let's look at some of the characteristics, starting with the a value. We refer to this as the stretch factor, sometimes also known as the dilation factor. Here's some things you need to know about the a value. If a is greater than 0, we say that the parabola has a positive orientation, meaning the parabola opens upwards and the vertex is a minimum. If a is less than 0, the parabola has a negative orientation, meaning the parabola opens downwards and the vertex will be a maximum. If the absolute value of a is greater than 1, we say that the parabola is narrower than y equals x squared. If the absolute value of a is less than 1, the parabola will be wider than y equals x squared. Now this does not mean that all fractions make a wide parabola. If the value of the fraction has an absolute value greater than 1, for instance if the a value is 5/2 or 7/4, then the parabola will still be narrower than y equals x squared. If we look at the h and k values, h and k values tell us the horizontal and vertical shifts. Taking these ideas together, we can find the vertex. The vertex for a parabola in this form is said to be at h, k. Now let's look at a couple examples below. In the first example, we're going to find the vertex, the stretch factor, and then the orientation. We'll use those to write the equation for this parabola. Beginning with the vertex is at the bottom of this parabola. It is a minimum value. It is down here. That vertex is at 4, 2. The stretch factor for this parabola, when we go over 1, we go up 1. This tells me that it's 1 and 1 squared. If we go over 2, we're going up 2 squared. When we go over 3, we're noticing that we go up 3 squared. This tells me that the stretch factor is a 1. Again, when we go over 1, we're going up 1 times 1 squared. Going over 2, we're going up 1 times 2 squared. When we go over 3, 1 times 3 squared. The stretch factor, again, is a 1. The orientation. The parabola opens upwards, indicating that we have a positive orientation. This tells me that the a value for this parabola should be a positive 1. When we write this, we'll say y equals, we don't usually put a 1, so instead we'll just say the quantity, x minus, we see that the h value in the vertex is 4, quantity squared, and we see that the k value is 2. We end it with a plus 2. Looking at this equation, we notice that again that the a value is positive 1. We see that the horizontal shift is 4, indicating 4 units to the right, and that the vertical shift is 2, indicating that the vertex is shifted 2 units up from the origin. Looking at the second problem, we'll use the same ideas to find the vertex, the stretch factor, and the orientation. For this one, the vertex is here. This would be over 1, 2, 3, 4, 5 units, and up 15. This vertex is at negative 5, 15. The stretch factor, when we go over 1, we're going down 2. That would seem to indicate that we're doing 2 times 1 squared. If we go over 2 units, we're going down 8 units. This is 2 times 2 squared. This tells me that the stretch factor is 2. This parabola opens downwards, indicating we have a negative orientation. Putting this together, we would know that the a value is negative 2. When we write the equation, we'll say y equals negative 2 quantity x minus. Now the horizontal shift is a negative 5. When I do the x minus, I'll make that x plus 5. Quantity squared. And then the vertex has been shifted 15 units up, so we'll then end it with a plus 15. This equation is y equals negative 2, quantity x plus 5 squared plus 15. Now let's look at a couple examples where we're going to have to do the graphs. The first example here is y equals 3 quantity x minus 4 squared plus 2. Let's go ahead and identify some of the key information. To begin with, we see that in parentheses, x minus 4. This tells me the vertex will be shifted 4 units to the right. The positive 2 at the end indicates that the vertical shift is a 2. The vertex is at 4, 2. Looking at the a value, a is 3. The stretch factor is 3, and it has a positive orientation, meaning the parabola will open upwards. We'll begin by plotting the vertex. 4, 2 would be down here. The parabola has a stretch factor of 3. This means when we go over 1, we'll go up 3 times 1 squared. That would be 3. If we do it 1 to the right, we'll also do it 1 unit to the left. The parabola must have the symmetry, meaning the points on the left have to be mirrored to the right. If we go over 2, we'll go up 3 times 2 squared. 2 squared is 4, times 3 is 12. We're going to have to go up 12 units from the vertex. That would put it 14 units above the origin. That would be right here. Mirroring that point onto the other side would be right there. We can now draw the parabola. For the next problem, we have the equation y equals -2 quantity x plus 1 squared plus 12. Looking for the vertex, we see that the parentheses has an x plus 1. This indicates that the h value is -1. The reason I know this is, in the form x minus h, a negative would make that plus 1. The vertical component is the plus 12 at the end. We know the vertex is -1, 12. That would be on the graph right here. The stretch factor can be determined by the a value. I see that a is -2. This tells me that my stretch factor is 2 and the orientation is negative. Plotting this, if I go over 1 unit, I'm going to go down 2 times 1 squared. 1 squared is 1, times 2 is 2. So I'll go down 2 units on either side of the vertex. When I go over 2 units, 2 squared is 4, times -2 is -8. I'm going to have to go down 8 units from the vertex. That would be over here, and again to the right. I can now plot my parabola. I hope this helps you to understand how to graph the vertex form for quadratics.